Let's continue this 1997 AP Calc AB multiple choice no calculated portion of the exam. We left off on number 16. This says the area of the region enclosed by the graph of y is x squared plus 1 and the line y is 5 is equal to, okay, so good idea to first do, it's a good idea to first sketch the region to kind of visualize what it looks like. Okay, so we know that this guy is a parabola. This guy is just a horizontal line. Okay, so it's a parabola shifted up by 1. That's this guy. That's the x squared plus 1. Another line, y is 5. Okay, so we want to find the area of this shaded region. How to do that? Well, remember area is upper curve minus lower curve. Okay, the upper curve is 5, lower curve is the parabola. Okay, so it'll be upper curve minus lower curve. How do I get the limits of integration? Well, you can easily eyeball it because you can plug in like easy numbers like 2, you'll get that y is 5. Or negative 2, you get y is 5. You get this is also equal to 5 when x is negative 2 or 5. That's not hard. To mathematically do it, you just set this guy equal to this guy. So x squared plus 1 equals 5. X squared is 4, or x is plus or minus 2. Okay, so our integral is from negative 2 to 2. Upper curve is 5, minus lower curve is x squared plus 1. Okay, this can reduce to what? 4 minus x squared. Okay, and actually, we know that it's symmetric. Okay, and we can do it mathematically here when we say that this is an even function. Okay, so we can split the integral up from, we can have it, so it'll be from 0 to 2, and we multiply it by 2 on the outside, okay, by symmetry. We could also just set it up from 0 to 2 from the beginning and put 2 on the outside. That's totally valid also, okay? But I wanted to show that it's actually from minus 2 to 2, and now by symmetry, we can just have it and then multiply by 2. Half the interval and multiply it by 2, okay? Because it's easier to work with zeros. Okay, so this is just power rule. That's 4x minus x cubed over 3. Evaluate from 0 to 2. So it's 2 times 8 minus 8 third. Okay, now it's just tedious math. 16 minus 16 over 3. 16 times 3, that's 48. So 48 minus 16 over 3. Or that's 32 divided by 3. Okay? That's this guy here. Okay, we have this equation. If you recognize, this is the equation of a circle with radius 5. What is the value of the second derivative at the point 4, 3? So we can just implicitly differentiate this to get dy dx, and then we differentiate that to get the second derivative, okay? So I did that over here. So x squared plus y squared is 25. That's the original equation of the circle. Okay, we implicitly differentiate, so 2x plus 2y dy dx is equal to 0. We differentiated both sides. Okay, we solve for dy dx, that's just minus 2x divided by 2y. Okay, so we move this to there, it'll be negative, and then we divide by 2y. We can simplify because these would cancel, so it's just negative x over y. Okay, so you can ignore this for now, but when we find the second derivative, we need the quotient rule. Okay, so it'll be bottom d top, so bottom I lumped the negative sign with the x. So bottom d top derivative of top is just negative 1 minus top negative x times derivative of the bottom is dy dx over bottom squared. Okay, so if we simplify, we get minus y plus x dy dx on top. Okay, we evaluate at the point 4, 3 because we want the second derivative at 4, 3. Well, plugging in the x and y is easy. X is 4, y is 3. Okay, what about dy dx? So this is why I wrote this over here. We want to evaluate this guy at 4, 3 also. That's just minus 4 over 3. Okay, so we plug everything in. Minus 3 plus 4 times minus 4 over 3 divide by 9. Okay, so we simplify, and then I won't go through all the math. You should get minus 25 over 27. Okay, so that's A. Okay, we have this integral from 0 to pi over 4, e to tangent x over cosine squared x dx. Okay, hopefully you can see that you can rewrite this as integral from 0 to pi over 4 e to tangent x. Cosine, 1 over cosine squared is the same thing as secant squared. So we can make a substitution. U is tangent x, du is secant squared dx, okay? So our integral becomes, let's worry about the limits afterward, e to the u du. What about our limits? When x is 0, u is 0. When x is pi over 4, u is 1. Okay, so that's just e to the u, evaluate from 0 to 1, which is e minus 1. Okay, f of x is ln of x squared minus 1. The f prime is what? You might get thrown off by this absolute value sign, but this is just this is there because of the domain, because log cannot be 0 or negative, right? So we just differentiate like normal. 1 over x squared minus 1, that's derivative of log, but we need to chain rule, so times 2x. So that is okay, so the thing here is, which one is it? So we have 2x over x squared minus 1. So it's immediately not e, okay? So which one is it? Where do the absolute values go? Or do we even have the absolute value, okay? As I just said, the absolute value is there because of the domain of x. The domain, okay? So does it apply over here now? It doesn't. So it's actually just d, okay? For example, we can even just like start plugging in points when you can, or actually you cannot graph this, but you can get the idea that, well, the ln will exist when x is like, when x is 0, okay, it'll be ln1, which is just 0, okay? So how would it look? We can even kind of visualize it real quick, okay? Because we know that log looks something like this. It looks like that, right? This is shifted by 1 even, so technically there'll be an asymptote at what? There is still an asymptote, okay? So it'll be like, okay? So because when x is 1, we get ln of 1, which is ln 0. Actually, ln of 0, which is negative infinity, okay? So it will look something like this over here. And because of the absolute value, it'll look like that over here also, okay? Now what happens in between, okay? Well, actually, you can already eliminate some of them because the slope of the tangent line at some of these points is negative, okay? Over here, it's negative. So it cannot be this guy, okay? And I think that we eliminated that one, okay? What about these? Okay, I'm trying to find a way to explain this. Would it help to know what happens here? Well, when it's 0, it's up here. When it's a little less than that, it's like this, I believe. I believe it looks something like this, okay? So if the derivative, so the derivative is negative over here. Slope to tangent line is negative over here. That's between some positive number between 0 and 1, right? This one would make it negative. Okay, so it would not work here because it's some number between 0 and 1. The bottom's always positive. The bottom, the top is always positive also. It is positive. So but the slope is negative. So it cannot be this one. We eliminate that, and then you can do a similar exercise, I believe, on this side. Between -1 and 0, this is always positive, but this term would be negative, but the slope is positive, okay? So that's another way to eliminate answers, okay? That's if you know how this generally looks. It looks generally something like this, okay? We move on. Average value of cosine x on this interval is, this is easy. Average value, that's 1 over the length of the interval, so 5 minus -3 times integral from -3 to 5 of the function cosine x dx, okay? So this is an eighth sine x, evaluate from -3 to 5. So that's an eighth sine of 5 minus sine of -3. Okay, we don't get one of those answers, so what happened? Okay, well, we know that sine is an odd function, so we can rewrite it as sine 5 minus negative of sine 3, so it becomes plus sine 3. Okay, and that is, yeah, this one. Divide by 8. Okay. We have this limit as x goes to 1 over, x over ln of x. Let's just plug in. We get 1 over, what's ln 1? That's 0. 1 over 0 does not exist, because it'll be infinite. Okay. I think it'll actually even be negative infinity. I would have to write it out to double check, but anyway, the point is, does not exist. Where all values of x for which the function f defined by this guy is increasing. It's asking when it's increasing, so we probably want to take the derivative of f, okay? Did I do this beforehand? I did. To take the derivative of this, we need the product rule. First d second plus second d first. Okay? This is f, so first d second, derivative of that is minus e to minus x, plus second d first, derivative of this guy is just 2x. Okay? We can factor out e to the negative x from both of them, so that's what I did over here. Okay? So we left with x squared minus 3 plus 1 times 2x, so that's just plus 2x, right? And I actually factor out a -1 also. So that becomes like this. And then I factored this. It's x minus 3, x plus 1, okay? So our critical points are x is 3 and -1, okay? So we do our first derivative test with the two critical points here. We plug in some number much less than -1. Well, e is always positive, but there's this negative sign, so we're going to say this is always negative, okay? This, when we plug in a huge negative number, would be negative. This would also be negative when x is a huge negative number. 3 negatives make a negative, okay? Plug in some number in between -1 and 3, like 0. This would be negative, this would be positive. This is negative, so 2 negatives make a positive. Plug in some number greater than 3. So this would be positive, this would be positive. This is always negative, so negative sign. Okay, so what is it asking? When it's increasing, that's when it's between -1 and 3. Okay. 23. If the region enclosed by the y-axis, the line y is 2, and the curve square root x revolved around about the y-axis, the volume of the solid generated is what? Okay, so again, for these, always sketch the region. So we know how the square root looks. Looks something, let me shift things up if I can. Square root looks something like this. Okay. Line y is 2, that's horizontal line here. And it's enclosed by the y-axis, so that's here. So I shaded the region in, okay? We want to revolve it about the y-axis. So I drew from the axis of rotation a representative radius r, okay? So the volume would be pi integral r squared dy. Okay, we're doing the disk method. Okay, so what is r? R is this length. What is this length? That's just the function, okay? So we want it in terms of y though, because we're going to integrate in terms of y. Y is square root x, so x is y squared. I just squared both sides. So it's pi integral from 0 to 2, we're integrating y, so limits of in y, so from 0 to 2, of r, which we said was y squared, so y squared dy, so that's just y to the 4th dy. Okay? Simple parallel, that's pi over 5, y to the 5th, evaluate from 0 to 2, 2 to the 5th power is 32, so 32 pi divided by 5. Okay, I believe you had 2 more problems for this no calculated portion. Okay, this one's pretty easy. If you recognize that, oh, they even tell you that this guy is a Riemann sum approximation for which of the following integrals, okay? So, how do we do this? Well, remember the Riemann sum is using right endpoints, okay? So, let me even write it. It's summation as I goes from 1 to n, f of x sub I, delta x, right? And it's the limit as n goes to infinity. All right, so delta x is b minus a over n. Remember that? And x sub I is a plus delta x times I. These are your sample points. So it looks like we're incrementing. Okay, so, well, we know what the delta x is because it's just this guy. Okay, so delta x is 1 over 50. So we're going to increment from a 1 over 50. So the first point is 1 over 50. We're incrementing by 1 over 50. So 2 over 50, 3 over 50, so on and so forth. So we know that starting from 0, which all of them are, so that doesn't help us. Okay, but we know that the sample points are f of x of I. X of I is 1 over 50, 2 over 50, 3 over 50. Those are the sample points, okay? So f is just square root. So it should be this one or this one or this one. Now, which one is it, okay? Well, so we can eliminate these two, okay? Well, okay, so first of all, the last point, since we're using right endpoints, it should be b, which is 50 over 50, which is 1. So we eliminate this guy, okay? This is the delta x. Okay, so this expression is the integral from a to b f of x dx. So there's no extra 1 over 50. So it's this guy, okay? That's how we do that. And this one, oh, this is easy integration by parts. You should be able to tell that right away because it's x times sine x. Something like that is integration by parts, okay? So we let u be x, du is dx, dv is what? Sine 2x, dx, v is minus half cosine 2x, okay? By the way, you could do this tabular method, that's totally fine. I'm just going to do it the long way here, okay? So it becomes uv minus integral v du, so minus half x cosine 2x minus negative half, so plus half integral of cosine 2x dx. And this, when we integrate, that is minus half x cosine 2x, that's left untouched, plus a fourth sine of 2x plus some constant c. Okay, so that looks like it is a integration by parts. We could have did a tabular method too. Let me just do it real quick. Okay, we differentiate u until we get to 0. Okay, derivative of x is 1, derivative of 1 is 0. We integrate just as many times, so minus half cosine 2x minus a fourth sine 2x. Okay, we go diagonally and we alternate signs starting from positive. Okay, so we multiply them together. Negative x over 2 cosine 2x plus a fourth sine 2x plus c. So that's the same thing. Okay, you can watch my crash course in integration by parts to review it. Review this if you don't remember. Okay, and that's it for the no calculator portion. It's not too bad. Hopefully this was helpful. Please like this video if it was. And please subscribe to the channel to show your support, and also to look out for the with calculated portion, which is I did already. It's not too bad either.